Simultaneous linear equations in three variables are solved with the following steps. Step 1. Write all three equations in the form of ax plus by plus cz is equal to k, and label the equations 1, 2 and 3. Or you could label them a, b and c. So basically get anything that has an x, a y or a z stuck onto it on the left of the equal sign, and any constants on the right of the equal sign. Step 2. Select one pair of equations and eliminate one of the variables. Call this equation 4 or equation D. And we would usually eliminate the z. It doesn't have to be the z, but we would usually eliminate the z. Select another pair of equations and eliminate the same variable, so the z, and call this equation 5, or you can call it equation E. Step 4. Solve the equations 4 and 5, or if you call them D and E. So if you did get rid of the z's in equation 4 and equation 5, you're now solving for x and y. Step 5. Put the answers from step 4 into 1 or 2 or 3, so into one of the original equations, and find the value of the third variable. So you are probably subbing in your x value and your y value to find your z value, your third variable, which is your z value. Solve for x, y and z. X plus 2y plus z is equal to 3. 5x minus 3y plus 2z is equal to 19. And 3x plus 2y minus 3z is equal to minus 5. So all three equations are in the form of ax plus by plus cz is equal to k. So they don't need to be rearranged. We have the letters on the left and the constants on the right. Label the equations 1, 2 and 3. So equation 1, equation 2 and equation 3. Or you could label them a, b and c. Eliminate z from two different pairs of equations. So we're going to take equation 1 and equation 2. We're going to multiply equation 1 by minus 2. So x times minus 2 is minus 2x. 2y times minus 2 is minus 4y. Z times minus 2 is minus 2z. And 3 times minus 2 is minus 6. Now we see that our z's will cancel. Minus 2z plus 2z will cancel. Then minus 2x plus 5x is 3x, minus 4y minus 3y is minus 7y. Then we have equals, and minus 6 plus 19 is 13. So now we have an equation in terms of x and y. We can call it equation 4. Then we take another two equations. It doesn't matter which two, so long as it's different. So again, we're going to go with equation 1, and this time equation 3. So you could have gone with equation 2 and equation 3 as well. So equation 1, we're going to multiply by 3. So x times 3 is 3x, 2y times 3 is 6y, z times 3 is 3z, and 3 times 3 is 9. And we don't need to do anything to equation 3, we just write it down. Now we see that the z's will match up, so we can cancel them out. So 3z minus 3z is 0. So 3x plus 3x is 6x. 6y plus 2y is 8y, then we have equals, and 9 take away 5 is 4. So we can now call this equation 5, or we could call it equation E. So now we're going to solve between equations 4 and 5 to find the values of x and y. So this is equation 4 that we created ourselves in terms of x and y, we eliminate the z's. And this is equation 5 that we created ourselves again, we eliminated the z. So we just need to solve those simultaneously. So we can either at this point get the x's to match up, one's a plus, one's a minus, or the y's to match up, one's a plus, one's a minus. It doesn't matter which way you want to do it. In this particular example, we're going to make the x's match up. So we have 3x and 6x for our x values. So if we multiply equation 4 by minus 2, we'll get the x's to match up, and one will be a plus and one will be a minus. So 3x times minus 2 was minus 6x, minus 7y times minus 2 was plus 14y, and 13 times minus 2 was minus 26. We just write down equation 5 as it is. We don't have to do anything to that. Now, notice that our x's will cancel. So minus 6x plus 6x will cancel. And then 14y plus 8y is 22y. 26 take away 4 is minus 22. And minus 22 divided by 22 is minus 1. So y is equal to minus 1. So now we put y equals minus 1 into equation 4 or equation 5. It doesn't matter which one. So we're going to go with equation 4, which is 3x minus 7y equals 13. So we swap that y for a set of brackets and we put minus 1 into the brackets. Minus 7 times minus 1 is positive 7. So we have 3x plus 7 equals 13. 13 minus 7 is going to be 6. And 6 divided by 3 is going to be 2. So x is equal to 2. So we were asked to solve for x, y, and z. We found y. We found x. Now we need to find z. So now we can choose any of the original equations to sub in our x and y values. So we're going to go with the top equation, but it doesn't matter which one you choose. So remember, we got x to be 2 and y to be minus 1. So now we put x equals 2 and y equals minus 1 into equation 1 or equation 2 or equation 3 to find the value of z. So we've gone with equation 1. So we swap the x for a set of brackets and we put 2 into the brackets. We swap the y for a set of brackets and we put minus 1 into the brackets. And then we simplify. So 2 times minus 1 is minus 2. So we have 2 minus 2 plus z is equal to 3. And then solving for z, 3 minus 2 plus 2. So these will just cancel each other out. So we'll be left with 3. So z is equal to 3. Thus, x equals 2, y equals minus 1, and z is equal to 3. Note, any of the variables x, y, or z could have been eliminated at the beginning. If one equation contains only 2 unknowns, then the other 2 equations should be used to obtain a second equation in the same 2 unknowns. So, for example, if you were asked to solve for 3x plus 2y minus z equals 3, 5x minus 3y plus 2z is equal to 3, and 5x plus 3z is equal to 14. Here, from equations 1 and 2, y should be eliminated to obtain an equation in x and z, which should then be taken with equation 3. So you don't always have to eliminate the z's. Usually it is the z's, but not always. So have a look at the 3 equations that you're given and see, is there one of them that's missing a variable already? So in this case, equation 3 was missing the y, so it was easier to eliminate the y from the other 2.